Okay, so hello. So this time we'll solve another challenge from Malware Traffic Analysis. This is the fifth installment. So we have here challenge detail. So we'll be using these tools. Okay, so we have a scenario here. So you're again an analyst working. You're a SOC analyst for a Thanksgiving team company. So one evening, problem came. So mail filters are down, spam everywhere. Okay, so a pretty nasty scenario here. But one example caught your eye, the blah blah blah. So here's the example emails received. Of course, being the SOC analyst, you have acquired the sample emails and even a pcap. So you have to figure out which email was used to compromise the system. Oh, pretty nice challenge. So we have here around 19 questions. Yeah, we have 19 questions. So without further ado, let's start. So first one, what is the name of the malicious file? So of course you have to download the challenge, which I already did. So I'm using now a Remlux machine. This is a malware analysis machine from Linus Seltzer, pretty good one. So we have here downloaded and extracted the challenge content. So let's begin with the email one. So open it. So since this is a Linux machine, I'm using an online email viewer. Okay. So for number one, what is the name of the malicious file? So we are out to open the email one, right? So this is the email one. So as you can see here, it's a fake invoice. So a phishing mail. So there's an attachment here, drawing wall. Let's use it. So we could actually save it. Okay. So once it's saved, so let's see. Oh, sorry. Okay, let's try to clear. Drawing wall. Okay, unzip. There you go. Okay, so as you can see here, there's an executable here. So the question is, what's the name of the malicious file? So this is exactly the malicious file. Okay, so that's how we got here. So number two, what is the name of the Trojan family the malware belongs to? So let's try and upload that file. Let's go back. So we have here this one. So let's try to upload. And what family is that? So based from, it's pretty malicious, as you can see, 61/70. And as for the Trojan family, let's see what's common. So as you can see here in the first row, we are already seeing the answer: opatre, 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 even the second row. And there's also a few hits here: escan, opatre. So how we found this answer. Okay, moving on. Number three, the malware dropped two files, malicious files with the same hash but different file names. Okay, so we have already hit the hint. Actually, I have here in the question 3. This is the 2015 hybrid analysis report. So we could actually see, this is my write-up. Okay, let's try. So as for the draft files, you could actually see here file sections, analysis. Okay, so as you can see here, SHA-256 4891 6FA 2FA 2FA 6. As you can see here, we have here two draft files with different file name, but same SHA-256, same hash, right? So let's see. So D1, so D18 4B9, D18 4B9, D18 4B9. Oh, actually, that's not the answer. D18. Yeah, so this one, D18 4B9. So this one, we have here two extracted files, different file name, but same hash. Okay, that's the answer. And for number 4, how many DNS requests were initiated by the malware? So we will look at the same hybrid analysis of the malicious file, hybrid analysis result. So for the DNS, there's actually 3. As you can see here, there are 3 DNS requests. Okay, so Rix Telecom, subdomain, and then voiparound.com, ICANN has it. Alright, that's how we found the 3. And for number 5, moving on, multiple streams contain macro in this document by the highest. So now we will deal with the second email. So let's try to open the second email. View. Okay, and as you can see here, so another seemingly phishing email. Indeed, a phishing email with the malicious XLS attachment. So for this, I think I've already downloaded it. You can already see here. Bills payment. Okay, bills payment. So not here yet. So let's try to download. Save. Okay, let's try bills payment. Okay, so there. So now since we are inspecting XLS, so all the file. So we will use the good old, yeah, so this contains macro and Excel with macro, so we'll use the good old dump.py and just point it to bills payment. And as you can see here, it has the question to answer the question, multiple streams, so provide the number of the highest one. So we have here the highest stream is number 20, right? Okay, number 6, the Excel macro. Try to download the file. Provide the full URL of this file for the second email. Okay, so to do this, simply open it. I'm on my right Remlux machine. So simply open it using any EML online viewer. Okay, as you can see here. Then we can download the attachment here. So simply click and it will be saved here. Okay, should be saved in the downloads folder. Okay, as you can see here, we have here the bills payment. So after that, we could simply upload it to VirusTotal. That's the easiest way to sandbox. You could also use hybrid analysis and the like. So there's the bills payment, and check the behaviors tab, and we can actually capture the HTTP request, and this will be the downloaded file. Okay, so that's how we got it. Of course, there are other ways around it. Okay. Great. Okay, next question 7. What is the name of the object used to get data from the download URL? Again, from the email too. So again, I used up here the hints, and Actually, the hint says get it from the variable from the BBA code. So what I did here is upload the malicious macro file. I uploaded it in malicious macro file here, the hybrid analysis. Okay, so you will find it. Search for the VBA references somewhere along this. Okay, let's search further. Embedded. Okay. Okay, there's a lot of VBA. Okay, based on the hint, we can search for this variable indicated in the hint. And as you can see here, okay, where is it? Entry. I did found this one. Okay, we can see here that the object that was used, and of course from here we could try to reverse it using a search. So Google Microsoft.xml. As you can see here, HTTP. So this is the closest one. Yeah, so we got here, and this is actually the format of the answer. As you can see here, starts with M, the X. So let's try. Yeah, Microsoft XML HTTP. Let's search how it's being used. Okay, so something like this. Right, that's how it's being used inside the code. Okay, so number 8, the Excel macro writes a file to the temp folder. Provide the file name. So here, of course, I tried this. We can leverage again the virus total results, the sandbox, the behavior. So since we're looking for the temp, we can just find. So I'm in the behavior tab to observe all drop files, registries, and so forth, network connections. So we now search temp. As you can see, there are only 4 matches. Actually, there's only 3. So this one, and this one. And as you can see in the answer format, it starts with T. So which leads us to roll out this executable. Okay. Okay, so number 9. we're now to the email tree. We're onto the email tree. So provide the FQDN used by the attacker to store the login credentials. So of course you have to open the, as you can see here, I use again Encryptomatic. So you could open the email tree contents and you will see this is something about the American Express. Of course, a phishing email is trying to masquerade as American Express. So there's an attachment actually right here. So click it to save it to your machine. And then open it. Okay, you can open it. This is actually a Remnox machine, so no worries. And from here, as you can see, it's asking to enter your details. So we could do a right click, view page source. From here, the key is to find HTTP keyword in order to find the domains or the URLs other than the online. So this is the legitimate one. So we need to find the other URL trying to pose as the fake online.American Express, and soon enough you will find this, which is actually the answer. Okay, number 10. Email 4. How many FQDNs are present in the malicious JS? So again, we can open it. Notice here, this is again a phishing email in the form of fax document. You can download the zip file and extract it, and you will notice after that it actually contains this one. It's actually a JavaScript. So what I did is I tried looking up in VirusTotal to see any behavior with regards to the domain outbound connections, but there seems to be no clear reference here. Even in any run, there's only one domain here. As you can see, Kennedy City. As you can see here, only one domain as well. But anyway, so I used up the hints here, and it says to check the Barbie variable using the JS. Okay, so this one is really file the JS code to make it more readable, and the hints is to check the Barbie. Okay, and if you scroll down, there seems to be 3 references that seems like a URL. So 1 under that Barbie, 1, 2, and 3. Okay, and actually that's the answer. So that's how I got this. Okay. Okay, Q11. So in the email 4, what is the name of the object used to handle and read files? Okay. So actually we'll continue to inspect the malicious binary. We could actually search for 8 search for create object. Okay. Yeah, continuous. Create object. Okay, fine. Okay, so actually right here in the JavaScript wscript.exe execution, there's actually a create object here, and as you can see here, it uses the addon create object adodv.stream. Okay, we could search further what is actually happening here. Of course, we could Google this out. So okay, actually the one I found is in Stack Overflow. So the question is to handle and read files. So yeah, so you could read some. So you will see that this is actually being used to read files. Okay, Adobe Stream. Okay, let me just get here a while. So this is actually my write-up. So okay, let's go back. Yeah. So here, set reference article. VQ12, the victim received multiple emails, however, the user opened a single attachment. Provide the attachment file name. So again, let's go back to our Brim. Okay. Okay. First, of course, we have to check which attachment from the 4 emails was opened. So let's reverse one by one. So I'll do it in reverse order since I know the answer. So let's start with the email number 4. And if you notice here, we have here in email number 4. This is the attachment, the fax blah blah blah.zip, which contain a malicious document masquerade, which is actually a JS malicious JavaScript file. And remember, we sandboxed it and we were able to find this domain C2 server. So we find it in the domain. Okay. Okay, we find it in the main query in the network connections. So we will reverse it. So let's try to find let's see in Brim there's a connection server.com. So you can see here indeed there's a connection in the pcap file. So meaning we can deduce that the user actually opened the attachment from the email 4. So remember this email 4? It has attached zip. So that's how we got the answer. Okay. So next, what is the IP address of the victim machine? So from this, we could again go back to Brim. Let's go back to the Brim. Okay, we could do security alerts by category. Okay, so we could do network Trojan, pivotal logs. Of course, there's just 2 internal IP here, the 174. Yeah, 174 and the 10.366. Oh, sorry, we just have one here. The 10.366.103 rather. This is the only internal IP. And this is actually the infected machine. Alright, so that's for question number 13. Okay, and then 14, what is the host name of the victim machine? So that can be easily seen using the Wireshark. So, okay, let's close this. So, in the Wireshark, okay, remove the filter. Okay, as you can see here, just check this is the victim IP. And we got here NBNS, NetBIOS name servers, and notice here the The resolved host name is trout-pc. So that's the answer. Where it is? Where is it? Oh, here, trout-pc. That's for number 14. And for the 15, so FQ at the end that hosted the malware. So remember, in the malicious JavaScript, this is actually the FQDN that we found. Okay, so that's for number 15. Okay, 16. The open attachment wrote multiple files to the folder. Provide the name of the first file written to the disk. So we can actually see it in the sandbox results again. So let's search for the tab. Okay, this is actually we are now in the written files. So here, file activities, right? So that's how we found this actually. So 7997552. No, there's an earlier one, the 551. So here, so before the 552, there's actually 551, right? Okay, so here's the fun part, number 16, the open attachment row. Number 17, one of the written files to disk is the following MD5 hash. So which registry key does this malware check for its existence? So remember, the Kennedy, so we have to export the objects from the file, the domain that hosted the malware, which is this one, C2 server. So if you really call this, so we could all save it, actually download all. Okay, you could download everything. Okay, we try. Okay, so that will download it for you. Yeah, I just have this error, but you could actually, there will be error, but it will be actually downloaded. And what you have to do is, of course, take the hash of it. Actually, the one we're looking for is this one. So let's take the hash, SHA-256. So if we're going to search, okay, this one, we're going to search for virus total. Okay, that's a very suspicious file. So the 256 of that, 47F, C8D, 47F. So if you could see, this is actually that file, the one with the 454 kilobytes. Okay, the SHA-256 exactly match. So this is the malicious file. So you have to move it to a VM that have a debugger, because we're going to debug, particularly the reg key. What you call this? Okay, so we're gonna open the hint since this is particularly the reg open key a function. So we're going to do a breakpoint there to inspect what's the specific registry key being checked for the malware existence. Okay, so I have here my Flare VM, and I already copied here the file. So you have to move it from your one VM to another VM with the debugger. So here, let's open X32DVG. So it's a debugger. Okay, we could use this one. And let's load that file, or the malicious executable. Okay, select. So remember, okay, since it has different extension, check all files. And this is the file with the hash in question. So open. Okay, then we set breakpoint. So remember here. Mhm. So it's reg open key A, reg open key A. So we set breakpoint on that reg open key A simply by typing the commands bp reg open key A and press enter. Okay, now that is set, so double check on the breakpoint. So we have here, okay, so we have here the reg open key A breakpoint, and now we can now run. Go back to the CPU tab, and we could now run up to the breakpoint. So run. So of course it will first go to the entry point. So again, click run, and as you notice here, reg open key A was hit, and what we could see in the ACX register, this is the one that's going to be checked. This is the exact register key value, which is actually the answer. Okay, so Q18, one of the written files of this was the following MD5 hash. This one, so send to HTTP post request by the web server IP. So this one will just use OSINT and available sandbox out there. Of course, we could search. Then you could search hybrid analysis, any run. Actually, I was able to find this on a Joe Sandbox report. So here's the exact link where I found the answer. So this is the answer actually. So the contacted host. So search for any Sandbox report and check the network contacted host section. So this is Russia and the related OSINT here. Okay, so that's how we got this one. And finally, number 19, the malware initiated callback. Traffic after the infection. Provide the IP of the server, destination server. Okay, so this one, fortunately, there's no Brim signature to help us find. Okay, so let's kill this first and restart. Wireshark is not cooperating. Okay, so we will do a Wireshark deduction. Okay, so let's open again the file. And okay, let's temp PC download. See if he works. Sounds DFIR downloads. Alright, that's weird. So this is the downloads folder. Okay, let's just drag it. Okay, we have here the pcap. Okay, we could do statistics, conversations, do TCP. Okay, that's weird. Oh, there you go. So we could sort by bytes. Okay, and notice here we have sorted by largest to smallest, and we could actually filter it. So okay, now it's filtered, and notice here there's even a malicious or suspicious HTTP request here. Okay, so but also follow the HTTP stream, and notice here a garbled or obfuscated link going to this. But of course, at this time of analysis, it's no longer existing because we can see here the response See here, the object is no longer there. But anyways, those two are the ones we found. So which means this is most likely C2 traffic. Okay, so that's how we found the last. Okay, so hope you have a good one. Cheers.